let's get started. All right, so, I've really been very excited to talk to you because there's so much new information and so much stuff what we're doing. And been working on a new lecture coming up. You may have seen it with two of my dear friends and two of my most respected colleagues, Dr. Carlo Ronaldo out of Australia, who's a chiro neuro, but also a PhD in vestibular rehab. I think he's one of the best, if not the best clinician in the world in vestibular rehab. He's the only one I know of that has a PhD that level, and he worked with some of the top people. And Dr. Peter Schreier, who I think is also one of the best people out there in functional immunology and neuroimmunology. And we're putting together a lecture, which is really a specialty lecture, trying to really bring the most cutting edge information and research that we've been doing. Also, experience from our clinical practices, new tools, new understanding, and ways to get better results. So I've been working on this really hard, putting a lot of information together and also applying it every day. What you see behind me is some slides, and I'm sorry that I think they're reversed for you guys. At least that's what it looks like to me, but that's okay because I'm not expecting you to read a lot. I'll talk about it, and I'm not going to go through. This is basically a preview of what I'm going to be presenting in April in a couple of weeks here in New York City. If you are a clinician out there, or an interested parent who's taken some of my courses before, this is going to be a pretty advanced course, so you should have some background. But we'd love to have you join us, and I think it's going to be a really fantastic event. Not sure if we're recording it yet, so it may be your only chance to see it live. But we'll let you know. And so this is kind of a preview of that. But also what you see here, I'm sitting in my office in New York. And if anybody has been here or any of the parents that I work with, this is how I present what we call our report of findings, meaning when we examine a child or an adult, we then sit down and review all those extensive testings that we do and really explain it in really specific terms as it applies to this person or this child and their brain, right? Because for me, it's really always about what's actually happening in the brain. What is actually going on that is presenting in your child or in the patient with the different symptoms or issues or conditions or concerns that you're here for. And that really is the bottom line, because if you can't understand what's actually happening in the brain, then obviously, then you don't know how to change that. And it's all about that. It's all about changing the brain in a very specific, directed way. And so, I've been doing this for 30 plus years. I've been a researcher. I've been a clinician. If you don't know who I am, I have multiple degrees. I have a degree in chiropractic medicine, but I also have a board certification in neurology, and then I have another board certification in rehabilitation. I have a master's in clinical rehabilitation neuropsychology, and I also have a PhD in developmental cognitive neuroscience. So this has been a lifelong journey for me. It's been a lifelong passion, really fueled as a father of three amazing children who all started out with gifts, but with different issues. And as I talk to parents especially, or adults, anybody that ends up with the kind of imbalance that ends up in our office, for the most part, there is no injury in the brain. There is no genetic mutation. There is no damage. There is no major metabolic disorder. They usually come from great families, so there isn't usually any traumatic issue. But what we see is that there is this maturational developmental imbalance that really starts with a gift. And I don't say that to make people just feel good. I'm saying that that's actually the neuroscience, that there are areas of their brain. When we say someone is gifted or talented, what does that mean? It means that there are areas of their brain that genetically, that is part of a trait, not because of a genetic mutation or alteration, but a trait that is passed down through their family, their parents, that gives them a little bit of an advantage in an area of their brain that controls their function. And it's usually more on one side than the other. Someone is, very good in math and can do calculations in their head really quickly and is really good with memory for facts and details. There's usually areas in the left side of their brain, specific areas, that can just process that information a little faster, have a little bit more connections, a little stronger connections. If somebody is, a good songwriter or musician, there are areas in the right brain that may be a little bit stronger. So, it really comes down to that. But when areas are really strong on one side, there may be a little bit of a deficit on that same area of the other side, especially if there's an imbalance that develops where one side gains too much of an advantage. So what we want to talk about tonight, though, is something that I've really been studying and researching for the better part of 25 years, which I think is one of the ultimate mysteries in neuroscience and in clinical neurology. And that question is, what is actually preventing some children from speaking? Why are they delayed? Or why do they actually not speak? Or why can't they speak? What is it? In things like, autism, non-speaking autism, which is really a lot of where my research revolves around, no one's ever answered that question. I mean, I've looked through all the literature for years, read thousands of papers and books, and no one has ever clearly come out and said, this is why they can't speak. There are different comments or theories. Most people believe that there must be something in the left language center, especially expressive language center, called Broca's area. Some people say there's a dyspraxia. Those are not actually the full reason in some kids. Some kids it is, and that's the primary reason. And some kids it's not at all, and it's actually the opposite. So what we see is that there has been a obviously epidemic rise in neurobehavioral disorders over the past 30 years. We're coming up on Autism Awareness Month. This is another thing that motivated me to come on now and kind of talk about this, because I want to raise awareness about how brilliant these kids are and about their gifts and how we underestimate them. And not just saying that to be nice, or not just saying to make that people feel good, or not just saying it from an acceptance standpoint. I'm actually saying it from an actual neuroscience standpoint, that they're brilliant, they're geniuses, but they can't show us. And I'm going to explain to you a little bit in general. Now, remember, I don't want to keep you here for 3 hours. I'm giving you an overview. I just want to give you some information. And then, talk about how you can find out more, of course. And we will be going through this in great detail in my upcoming course that we're doing, and really talking about very specific details about what to do about it, and some really cutting edge tools we have of looking at the brain and imaging the brain at the highest level and changing it in measurable ways. So we'll be presenting that tool at the conference that we have coming up. But we see, especially since the pandemic, that there's been a very big jump in childhood speech developmental delays. When talking about just kind of speech delays, and again, in this paper that I have behind me that talks about this, then it's not clear whether they're relating this to non-speaking autism, but we know that non-speaking autism probably makes up, or low speaking probably makes up about 40% in the autism spectrum, and that part is increasing, and that part of autism, I believe, is increasing faster than the ability to speak part of it. And so obviously that's a concern for people, because everybody wants to be able to see their child speak. Every person wants to be able to speak, but nobody's really understood why, and that's what I want to explain to you. First of all, there are left brain reasons and right brain reasons why individuals don't speak. So when you get a child that is speech delayed, what often happens is that if they're not speaking by 3, which is way too late to get a diagnosis or to intervene, not too late, it's never too late, but it should happen earlier, and I'm going to explain how that happens. But there can be either a left brain delay or a right brain delay. The most common diagnosis of a child that is 3 years old and not speaking is basically PDD, NOS, or milder form of autism. Sometimes it might be diagnosed as full-blown autism. However, we know specifically, I'm going to talk specifically about what is happening in autism, and it might be that, but what we might see is that it may be more of a left brain delay, and those people may grow up to have other types of issues like dyslexia, processing disorders, learning disabilities. When they grow up, it might become bipolar. Type 1 ADHD is another thing that's associated with a left brain delay and overactive right. Dyscalculia, problems with, basic math and math operations. And there's many other things, really high levels of anxiety, social anxiety, many, many things. And this comes from overdevelopment in people that are generally gifted in their right brain, and where there's an alteration in growth and development. On the right side, with a language delay, it could also be a right brain delay, where their left brain might actually be online and come online too early. This is what we typically see in autism spectrum, but there may be other types of right brain deficits like ADHD, more classic, combined type, OCD, tics, stimming, behavior, schizophrenia when they get older, and many other things that are more related to right brain delays. So the bottom line is, if there's a language delay, it's always due to some sort of immaturity or delay or developmental change in the way their brain is growing, and it usually represents some sort of delay or imbalance. I mean, obviously it's a milestone that should be met. Most kids should be clearly speaking 3 to 5 words at least by the time they're 1. And they should be at least 50 words by the time they're 2. So we know that there are standard values and milestones in language. But what we have to always think about and get to is, what is the foundational root cause? What is actually happening at the root? Because otherwise you're just managing symptoms. You're not really dealing with that core issue. And again, understanding whether this is a right brain delay or a left brain delay and how it got that way. If you don't understand that, then you don't really understand the root cause, and you can't change it. Because the bottom line is, this is about trying to change it. Not trying to change the person, the child, or the patient, because they're amazing as they are. What we want to do is be able to help their brain to develop to the optimal level for them, meaning to become the best version of themselves. As a parent, that's all we want. But if there are certain developmental issues that are there and that are at the root cause, then they're not the best version of themselves. And that's all we're trying to do. We're trying to help that happen. If the family wants that, if the patient wants it, if the child wants it. And I have to say that, the more and more that I've dove into this question and tried to understand it, it's been really a fascinating journey. From a scientist standpoint, trying to understand this has been really one of my lifelong passions. And what's really cool is, of late, over the last few years, since we've been working with a new technology and people that help individuals that can't speak to spell, even though they may not be able to type or write, but they might be taught to be able to spell on a letterboard. They might need some assistance, they may not. There are different techniques for that, but the bottom line is, it's called spelling. And with that, it's been able to open a world where we can actually hear from the child themselves why they believe they're not speaking, or what they're actually experiencing. And this is amazing to me because, for years, what I've tried to do is speculate. What is happening? What are they thinking? What are they doing? What are they feeling? What's going on with them? And that's what every parent wants to know as well, too. And we haven't really been able to communicate with them. And that's why we're here, because they haven't been able to speak. And yes, that a lot of that is, maybe our deficit as people that are speaking. Is there a possibility that not speaking is a new evolution of the human brain and consciousness? Yes, absolutely. There's a lot going on. There's something called the telepathy tapes out there, if you're not aware of it. It's really pretty interesting stuff. And again, for me, I like to think about all of that stuff from a scientific standpoint. And we'll talk a little bit about some of that in the lecture that we have coming up in April here as well. But for me, it's more about the same things that allow these kids to spell when most people think they don't even know how to recognize a letter or know anything, but yet it turns out they may be able to spell and full sentences and come out with information that is just absolutely amazing. Man, I could tell you stories that would blow you away, but some people will find that incredulous or say, no, that's impossible. It isn't, but I get that feeling. I get that understanding. But with that, I've been able to ask them questions I've always wanted to ask people. And they have taught me more about this than almost any other researcher and scientist that I've ever met. I've learned a lot, obviously. Anything I've put together or learned, I've learned for other people's research as well as my own research. But so it's always a team effort. But the way to organize it and put it together, I think I've been able to do that in a fairly unique way because I have a unique perspective and a unique combination of expertise and experience. But having these kids communicate and being able to express in detail what's happening in their brain, as well as the books. There are so many books that are out there that have been written by people who've grown up not being able to speak. Most of them on the autism spectrum. What we see is that they've been able to tell me things about what is happening and give me insight into what they're feeling, and that has kind of put the final pieces in. And I've been looking at this for a long time, and I've speculated and put together, and I did write a paper about this that was published last year on interoception and proprioception and autism and primitive reflexes. And it's out there, and you can get that paper. It's open access. Came out in 2023, I believe, as part of our large double-blind study we did looking at primitive reflexes and autism spectrum in kids and adolescents and adults. So it has been just an incredible journey with some of these amazing kids and families, and it's been an exciting time, and that's why I wanted to bring some of this to you, because I know this can be a really, really painful topic and difficult. So I'm going to kind of give you the abridged version of this and just kind of get to, and there's some images I'll show you and to help highlight this and just put this out there because, again, I know it may be late for some of you and we don't want to keep you too long. But so for me, the way I look at it, the human brain is one of the most sophisticated things and complex things in the universe. There's still so much we don't know about it, but we do know a lot about it. And I believe that can't be just randomly built, meaning the way we build it and develop it, especially the human brain, as I'm going to go through, there has to be very clear steps. So when I teach doctors or when I talk to parents, I talk about what's called a brain developmental blueprint. There's a specific blueprint, I believe, to the way the brain is most optimally built. And, now what you hear from even the CDC during the pandemic, they've said that those milestones have changed dramatically, where they even say that crawling isn't a milestone anymore. And I believe that's completely wrong. And I think it just highlights that they really don't understand brain development. They don't understand how to do it. And listen, I have many pediatricians that are friends of mine. I have someone that's working with me now in New York City. And I actually showed her much of these slides, and she looked at me and said, "Yeah, I didn't really learn any of this, so I don't know. I don't know the answer to most of these things that you're talking about." But she found it very interesting and fascinating, and felt that pediatricians should know this. And in many ways, they used to do a lot of these things. But I think that there is a very specific way that the brain is supposed to be developed. And, we hear a lot now that, oh, yeah, there's this wide variety and kids develop differently and, it's okay, but it's not. I think it's very specific. If you were building your dream house and you hired an architect and you had him draw up a very specific blueprint of how that house should be built, you wouldn't give it to a contractor and say, it's just a guideline, just do whatever you want. No, you would say stick exactly to the blueprint, right? Because if you don't build it exactly as the blueprint, the roof could fall down or something could go wrong. And that's your house. The brain is much more complex, I guarantee you. So I believe that there's a very specific and narrow plan, and especially in the human brain. Why the human brain? Because our brain is unique. Of all brains, it's unique, and we know that. Obviously, we have a unique level of intelligence. We have a unique level of self-awareness. It doesn't mean we're the only ones that have intelligence or self-awareness, but to the degree we have it. And basically, what we see is that one of the things about the brain is that we have basically the largest brain per body size of any primate. But because we are bipedal, we stand up on 2 feet, we have the smallest birth canal. So this is where the initial kind of problem and maybe one of our adaptations that made us actually develop the brain we have started. We have big heads with a small birth canal. So right from the beginning, we know that that pathway through the birth canal is dangerous and difficult for humans. But what we've had to do is be able to come up with a way to regulate that in some way and compensate. And so nature has come up with that answer in how we regulate the genes that grow the brain. And the genes that grow our brain are about 84% of our genes. So of our whole genome, the vast majority of them are really there for growth and development of our brain, not only just early in life, mostly early in life, but also for the rest of our life. I believe our brain is actually probably still maturing to some extent until we're about 50. There was research out there that said that the brain is developing till we're 25, but that study only went up to 25. But we do know that the brain is still myelinating, meaning developing fat around the cells and everything, until 50. So I believe that it's still kind of developing. So what we see is that anything that alters that development can affect us at any point in time in our life. So the genes that regulate brain development also happen to be the most sensitive genes to any sort of environmental input. And that's a good thing and it's a bad thing. It gives us great advantage. It makes our brain extremely adaptable. It also makes our brain very vulnerable. Most of the vulnerability is not damage or injury or genetic mutations, but rather what we call epigenetic factors that one of the things is called DNA methylation. This was just a study that came out behind me looking at neuropsychiatric disorders and looking at placental DNA methylation as really the primary issue that starts it off. So, there's many different things. My third book was all about this, Autism, the Scientific Truth, was all about, what are these factors and epigenetic factors. But what we see is that, again, uniquely to the human brain, our brain is the most immature brain at birth. And it's very small compared to where other animals are. It may be at the same size, but relative to where our brain grows, it is still very immature. It's only about 20 or 25% of the adult size, but in the first 3 years, it will grow to be about 90%. So there's this massive growth that occurs. But it also means that 75 to 80% of the growth of our brain occurs outside the womb. No other animal has to do that. No other animal has that level. And because our brain grows very big, it takes a long time. So there's a long time of vulnerability. And because our brain is growing outside, anything that alters the way that our brain is growing and developing can have a big impact on the way our brain ultimately functions. And what happens really in the first 6 years is what's going to be the fate of the adult brain. So developmental issues don't just impact childhood, they can impact development later on. Like schizophrenia may not develop until your 20s, but we know it's there from the very beginning, meaning that it starts in early childhood. And really the same type of problem can manifest very differently, but primarily they're either more right brain delays or left brain delays. And the genes that regulate brain development are very sensitive, and especially to sensory input. Outside the womb, the environment is different than inside the womb. We don't have as much light or sound or everything in the womb. When we're outside, we're bombarded by these senses. And the genes that build our brain are called experience-dependent genes. And so therefore, when they're outside, they know, okay, now I can grow, right? So before that, we have to restrict the growth of the brain, because if it's too big, it won't get out. And that's not conducive to survival. So obviously nature had to come up with a solution, which was keep the brain relatively small until we're out. And then once we're out, the genes can be turned on and grow. But trick is, we need movement to be able to initiate this. We need to be able to move. And if you look behind me, there's what we call Brodmann area, and there's an area number 4 up there, and that's the motor cortex. And that is what basically gives us the ability, when that matures, to move our body in purposeful ways, not just automated ways, but we can move it where we want, when we want. And then as we come forward in the brain to areas like area 6 and area 8, we can do more complex movement or motor planning on the left side of our brain more. But the problem is that we don't have that part of our brain there when we're born. It's not really online at all. So babies don't have really control over their own movement purposefully. So the problem is, we need to move to initiate those sensory input so that we stimulate the genes and we build the brain, but yet the part of our brain that helps us to move isn't there. So what's the solution? The solution is that we're born with these things called neonatal or primitive reflexes that come from the bottom of the brainstem, called the medulla and the pons primarily, and they are online when we're born. And the brain, as I'm going to describe, is built from the bottom up, and so the bottom of the brain is most active when we're born, and that's where these reflexes come from. And they allow for basic, simple movements that allow us to survive and allow us to be able to initiate the sensory world and engage the world and calibrate our brain and grow the brain. And these movements are there pre-birth, so that a baby at the end of the 3rd trimester miraculously gets upside down and backwards in the womb, and they should do that without the cord being wrapped around their neck, and they should get deep enough down in the pelvic canal that they ultimately induce the birth process. How does that happen? It happens because of these primitive reflexes. These primitive reflexes are coming online as the brain is developing, as that brainstem is becoming more active, and it is now, if the timing's right, their movements come about at just the right time, at around 9 months, 40 weeks, when they're going to be born. But there are many children that have breech presentation, that are not in the right position, or a sunny side up, or have the cord wrapped around their neck, and they may not be able to get out easily. And so, why? Well, to me, that signifies that maybe these genes aren't being expressed as they should be in the womb, and that maybe that brainstem isn't becoming active when it should, and these reflexes are not coming online when they should. And so, to me, there's already signs that there might be a developmental delay. Now we know that many of those children may end up having a C-section, and that is, to me, a signal that, okay, something... And remember, nothing that I'm saying, please don't ever feel judged or feel like there's anything going on that way. I'm just kind of trying to share information about this, and I understand that, how these happen. And this is not meant to make anybody feel bad in any way or say it's anybody's fault, because it's not. But, if there's C-section, it may be totally necessary, but those reflexes then should be used for the baby to come through the birth canal. And if they're not coming through the birth canal, then they're not using those reflexes. So if they're delayed and they're not going through the birth canal, and then they don't go through the birth canal, they may be more delayed in their onset, just putting the child a little bit further behind. And then if they come through and the baby is supposed to assist in their birth, they use reflexes like the spinal galant to push themselves out, and the asymmetric to twist down to the right, and then the tonic labyrinthine, as they come out, it makes their body extend and helps them push themselves out. If they're not doing that, then they need something like forceps or vacuum extraction. Or I had one mom the other day, the doctor had to jump on her tummy and push a baby down. Again, none of that should have to happen. A baby should never have to be touched, really, when they come through the birth canal. It should be a natural, relatively easy process and on time. If it's not, again, there's a reason. And that reason is, I believe, mostly that there's some brain developmental delay, that these reflexes aren't engaging the way they should. And once they're behind a little bit, then if you're behind on one milestone, you're going to be further behind on the neck and further behind on the next, and so on and so forth. The first milestone outside the womb is latching. What we have found that in children, especially with language delays, that about 90% of our patient population did not latch on appropriately, or fully, or some of them at all. And many of them had reflex, which again is part of that sucking and swallowing type of reaction. Many moms also will say, I wasn't producing enough milk and it was my fault, or my nipple was inverted and I need to use a nipple shield. Any of those things could also be explained by the child not fully latching, not stimulating the nipple fully, not stimulating oxytocin in the mom's brain, and the letdown of milk. Especially if on other children that the mom had, there wasn't any problem with that. So again, it may not, be the mom's fault at all, but rather this is another sign that that reflex wasn't fully engaged. If you need to have someone come and coach you on how to do it, if it's extremely painful, even though those things may be common, it's not ideal, and it means something. It means that they may not be latching. Yes, I know that there might also be a lip tie or a tongue tie, but I think those are overdiagnosed, and even when they're there, they may not change much. Then there should be these milestones that they should go through. And as I've said, I think there's a blueprint, and it should be really pretty strict, and we've known about this for many, many years. And, they should be able to roll over 3 to 5 months. They should then do the commando crawl, and they should do it properly and symmetrically. They shouldn't do the worm. They shouldn't hop. They shouldn't be like bunny rabbits. They shouldn't hate being on their stomach. If a child hates being on their stomach, again, to me, that is signifying that their milestones in their reflexes aren't coming on when they're supposed to. Then they should get up on all fours and they rock, and that activates the symmetric tonic reflex, which inhibits the tonic labyrinthine reflex, and then they should crawl symmetrically and evenly. They shouldn't drag one leg. They should not scoot on their butt. They should not just roll. They shouldn't drag one leg. They shouldn't hop. They shouldn't walk like an elephant. They should do it in a very specific way for a specific period of time. They should be able to sit up. They should be able to pull up, stand up, and then walk along the furniture. And then right around 12 months, I look at maybe 11 to 13 months as my window of optimal. All children should walk a few steps. They should say a few words, 3 to 5, and they should clearly point and have eye contact and wave and have nonverbal communication. All of that should be happening. If the reflexes aren't coming on and they're not fully coming on, they're not going to go away. And if they don't go away, then they may not go away at all. And what happens is, if they're missing any of those milestones, and especially speech, then something went awry. Just things didn't happen the way they should. And the more and the earlier you can recognize this, and the earlier you can start to intervene, you can change it. And by engaging the reflexes, bringing them out, we have to bring them out before they go away. If they don't come on time, they're not going to go away on time. And this is the problem. To me, this is one of the main problems. But what does that actually do to the brain? Well, what we see is that at 1 year old, really with the Babinski going away on the foot, that should be right when the child takes their first steps. And that should signify that the last of the reflexes are gone. And so then it allows the brain to get to the next level, which is much more sophisticated movement, much more complex movement, much more interaction with the environment, which creates a more complex brain, which then leads to better function. When we talk about the brain growing and developing, we're not building more cells. We have all the cells when we're born, but we're building connections, and the brain cells start connecting with each other like crazy and forming connections and forming networks that start working their way up the brainstem into the brain, and then ultimately form the networks in the brain on the right and left side. And there's a balance also between what we call short-range connections and long-range connections. Short-range connections are what we see first in an immature brain. They form and they give local connectivity, and they're very powerful connections and slower brain waves. But then as the brain matures, we should lose some of those and we should replace them with long-range connections that, now connect networks to one another and areas of the brain that are distant, and the two hemispheres should be connected together. That ratio of short-range to long-range connections is critical. There's a very specific algorithm. It's pretty complex. If we look at what's called graph theory, it's been calculated out, and it's different for different size brains. Human brains, again, are unique in that. But there's a very specific ratio. So that even with the exact same connections in the brain, what we can see is with a more immature ratio, where we have too many short range and not enough long range, it reduces the efficiency and speed of communication significantly, to be the difference between a person being a genius or the person being severely delayed. That alone could make a big difference. So we've actually done research, we've done studies, and other people have as well, where we've shown that in developmental delays, like dyslexia and autism and ADHD, that there's more short-range connections and less long-range connections. So what does that mean? It means that, again, the brain is in a more immature state. And this is what we showed with our research, because what we're saying is that when the brain when the reflexes don't go away, it represents that the brain is still in a more immature state. And when they don't go away, they actually hold the brain back. They keep movement more simple. They keep the brain in a less complex state. And they really basically start to hold back brain development. When the brain cells grow, as the brain cells grow, they get bigger and thicker. We don't grow new cells, but they get bigger and thicker, and they get faster impulses. So what we see is brain waves get faster as the brain cell matures. And again, we showed studies that in autism spectrum and other disorders that they have slower brain waves, which represent immaturity of the brain. So when the brain's being built, my analogy is like building a house. You start from the bottom, you start from the foundation, and then you build up in layers. So before you're going to put other floors and build a roof, you want to make sure the foundation is solid. And I'm going to get to regression in a second. That's a good question. So I'll talk about when they regress, okay? But so they should be, solid. The foundation of the brain, as I said, is down here in the medulla and the pons, and that's on line first. And that is the foundation of the brain. We need that foundation to be solid for everything on top of it to be solid. What does that mean by being solid? It means that it needs to be mature. How do we know if it's mature? Well, if the reflexes are still there, and if the milestones weren't met, or even if they were met but they weren't done in the right way, then that area is not, that foundation is not solid. And unless we do something, it will never be solid. And so the brain builds from the bottom up in stages, and then the brain grows, and then it comes down and it regulates everything. And I mean everything. A lot of what we're going to be covering in our new conference that we're having in April is the idea that the brain and the cortex and networks in the brain take the lead in the immune system. This is really new. I mean, there's some people have been alluding to it, but not to the degree that we're going to be talking about it or what's coming out now in research. Most people in the immune world think that the immune system just operates on its own, just with chemical signals. More and more it's being shown that no, that is all directed or is influenced dramatically by the brain down, regulating it, and by the brainstem. And so we'll talk a little bit about that, but that this is really the way it develops. And again, it starts with these primitive reflexes at the foundation. And then once they go away, we have more complex sensory motor interaction. And then in the brainstem are the precursors to all of the cognitive abilities that will eventually emerge in our brain. So literally these cognitive, like seeds in the ground, they need to be grown into the brain and then emerge. And that's when we start to develop these different cognitive abilities: speech, nonverbal communication, memory, learning, reading. They emerge in the brain, and once they've grown in the brain, now we can learn by using that. But until they've grown and emerged in the brain physically, using that stimulus is not going to make that grow. Meaning that if a child's brain hasn't on the left side grown in the area that is going to let them read, exposing them to books or trying to get them to read isn't going to make that happen. If a child doesn't have nonverbal communication, you can be giving all the signals from the parent and it's not going to happen. You can be giving all the signals and attachment won't happen. Emotional regulation won't happen. Socialization won't happen. Those things can't be taught after the fact. They need to emerge, and they need to emerge from the bottom up. And a lot of techniques really go right to the top of the brain. They go right to the roof and they try to influence it there and use those different stimuli, like try to, teach them how to behave. But the areas of the brain that should register that aren't there yet. So it doesn't work. You have to start from the bottom, and then you can start to do that as you make those things emerge. And then they have their cognitive abilities, and then they can learn. Okay, so that's really the way it works. And again, all this starts in the brainstem, and all of the reflexes that we look like come from the brainstem. And when the brainstem matures, there are areas of the brain that grow, and all these different areas that I've alluded to, called Brodmann areas, that have been mapped out, and they are different on the right side and the left side of the brain, and they do all different types of cognitive and motor and sensory and immune and autonomic and all different types of things emerge in the brain, and the right brain and the left brain are very different. Now, the way that happens is very important, because we need to have a certain balance between the hemispheres so that they need to be integrated, they need to work together. But if they're not growing and developing in the right timing and in the right way, that may be prevented. Information should be able to flow back and forth fluidly and easily. But if there's an imbalance one way or the other, it blocks that flow. And we know that the right brain develops first. So the right brain develops in the womb and for the first 3 years approximately. And then the left brain grows. And that's the way it's supposed to happen. And those steps are very important. But what we've been able to show in our research and what we see happening is that if those reflexes don't go away, the right brain at the first year, and sometimes this left brain comes online way too early, the right brain in the first year to second year is really hitting its peak of development. And if the reflexes don't go away, it holds back the brain development a bit. And when it holds it back, it's going to have more impact on the right brain, since the right brain should be in its peak of hitting its peak of development. And so it's holding that back more. And now the left brain, if a child is very gifted in that side of the brain, can come online too early, and then it gains dominance too early, and it can push that right brain down. So it can either slow it down so that a child might be saying some words, but then they don't gain them. They might be having some pointing and then don't progress. Or they may seem like they're even developing normally, but then the left brain comes on, pushes it down, and they lose everything. And especially the right brain is about feeling our body, connecting to our body, developing a certain level of self-awareness. And this is where we see that might be lost, like a child who's responding to their name and then stops responding because they were starting to become an emerging person, and then they lost it, because that is where you develop it in the right side of the brain. This also, as we're going to talk about, has an impact on the immune system. Also, any sort of immune overactivation at that time and inflammation that may ramp up more can also contribute to that. So we can get a perfect storm, because the peak of, there's also a major growth spurt right around 2 years of age, where we often see that left brain really zooms on, or around 3. We just had a child recently who has said that he knew, and he spelled this to us, that he wasn't fully autistic when he was born, and he remembers stuff, and he knew he could do things. And then he said it wasn't until 3 when it really hit me, it really kicked in. and he then lost it. And he, and that was where I believe now the 3 is when the left brain should fully come online, and then it may drop down. And then if this imbalance is established, it doesn't self-correct. Now, on the other side, with a left brain delay, I believe these are kids that are gifted in their right brain. So they're coming on, and the right brain is coming into its peak, and it should be really accelerating, but now it's being held back by these retained reflexes and lack of growth. So it slows down, but it's still stronger. And what it's doing is it's slowing down in its development, and it's holding this side down more and longer than it should. And then as it gains too much dominance, it then gains too much control. The right brain should be the more dominant one, but if it's too dominant, it crashes that left brain, and then they may not speak also because of the left brain, or they may be very delayed, or they may end up with dyslexia or other left brain types of issues like that. So that's what I believe what's happening with regression. So what we know is that a lot of these are built on traits. So they're family traits, and they're good traits. They're not bad in any way, but they're just, everybody, I believe, is a little bit more left brain dominant or right brain dominant, just like you're either more right-handed or left-handed. And so we know there's an autism trait, which is really more of a left brain dominant trait. And Simon Baron-Cohen of Cambridge showed that in kids or families of kids with autism, there were many more physicists, engineers, and mathematicians. He later showed that there was also more people in the finance world, or doctors and lawyers and PhDs. He also showed that anywhere where there was a concentration of people in the IT industry. What do all these occupations have together? They're very left brain dominant traits, and obviously very bright, very intelligent people that do that. On the other hand, there's a bipolar dyslexia trait. And what is that trait? Well, one of the features of that trait is that we know that it runs in creative families. People that are very right brain dominant, or people that are athletic, or people that are very social. People that may work in the healthcare industry and be, people that are out there and very empathetic. So this is what we see is the bipolar trait. With any trait, it should fall towards the middle. Like most people are average height. Most people have average intelligence and fall in an average range of a bell curve. But there are some people that are way above the curve and some people that are way behind the curve. And, some people that are way ahead of the curve, some people might be 7 feet tall. Other people might be 4 feet tall. The people that are 7 feet tall might have an advantage for certain things. People that are 4 feet tall might have a disadvantage for certain things. Same thing with IQ. We get people that are to the right, 2 standard deviations or above, that's 130 or above, that's considered genius. We consider that an advantage. 70 and below, we consider that a great disadvantage and a disability. But what we see is when these traits are really high on one side, if both parents pass on really strong genes for a particular trait, or there's somebody in the family that has really strong genes, the trait can be too high. And if there's an imbalance that accentuates that strength, and it also accentuates the weakness, then what happens, that trait can get too high, and if it does, then it goes over what we call a cliff edge, and it becomes a disadvantage. Up to that point, it usually gives great advantage. That's why we see that these issues are increasing in society rather than decreasing. So the bottom line is, what we see is that as the brain is developing and the right side is developing what it does and the left side, we're also developing these things called maps in the brain. And the way that starts is with an area called the insula. And this is a key area. So the insula is this area right here, and it's underneath the main cortex. And it is developing first as the brain is growing. And in this area, this is the area where we get what's called interoception. It's where we feel our body. This is where we feel different things. A child from the very beginning needs to tell the parent when they're in pain, when they're hungry, when they're thirsty, when they're tired, when they're hot, when they're cold, when they need to be changed or go to the bathroom. And this is where a sense of smell initially come together and emerge, so affect our eating behavior, like if a child's extremely picky or not. So starts in this area here. And then from there, when we start connecting to our body, and then eventually we become embodied in that area, and the anterior cingulate, which is an area just in front of it and inside. And that's where we develop a sense of self-awareness, and what we get, body ownership. We own our body. This is our body. But part of that is also related to proprioception, meaning that the awareness of where our body is in space. As we're moving through the world, we're also getting signals coming in that are helping us to build a 3D map in our brain of our body. And this happens in this area up in here called the parietal lobe, area 312. And we literally build a map in our brain. And a large part of that is because of input from the inner ear, the vestibular system. So this area back in here, this is the parietal insula area on the right side. And that is also the primary area for the vestibular input. So the parietal insula vestibular cortex develops there. And it helps to take input from our inner ear and really help to build this map to know where we are in space. Now, where does that information come from? It comes from the vestibular nuclei in the brainstem. But if the brainstem isn't mature, then those nuclei don't mature. And so there's nothing wrong with the inner ear input. It's coming in, but it's not registering here. And then if some of it does trickle up to the right brain, it doesn't really register there if the right brain is delayed, if that left brain came online too early, because the left insula is also developing. And that is an area that will develop more language, or it actually develops more of a sense of other types of things that will actually inhibit that right insula and slow it down and stop it and disconnect us, where we lose interoception. And we know many kids on the non-speaking end of it, especially on the right side, they have a deficit in that area of the insula and the anterior cingulate, and they really have low interoception, many of them. They have very high pain threshold. They don't feel hot and cold at the right level. They may not feel hunger and thirst. They may not really know when they have to go to the bathroom, so they may take a long time to be potty trained, or they may not be potty trained. They don't feel tired, so they may not sleep at night, and their sense of smell and taste is off. On the other side, if there's a deficit of the left insula, we know that that's related to dyslexia, and that may be related to pure language developmental delays and true apraxia. So we know that this does happen on either side. So there's this balance that occurs in those two areas. So what we literally have is we literally form a map. And we form a sensory map here, this little blue strip here. That is a sensory map. And literally it forms a map of our body in our brain, where we see our body in our brain. And we feel it. And we know where it is. And then in front of that, in the motor strip area, here, and we develop a motor homunculus, a motor map. So first we need to feel where our body is, and then we can move our body the way we want. So, you can close your eyes, and if I said to you, take your right pointer finger and touch your nose, it means that you know where your pointer finger is, you know where your nose is, and you know how to move just your pointer finger and get it to your nose. How do you know that? First, you feel where your body is, and then you can move it in a specific, purposeful way. It's very different than automated movements, which are kind of generated by the left brain and the basal ganglion, and it's just kind of spit out programs, random programs of movements, stereotypical movements, which is what we call stims or ticking. It's very specific. And if you look at this map, the biggest part of the map is the mouth, the face, and the lips. That usually, for most humans, is where we get the most sensory input. We have the biggest map there. And then we have the biggest map on the motor side. Speech is the hardest motor act that's ever been achieved. It's very difficult. And unless we have really full sensation of our mouth and our tongue and our lips and our throat and all of those things, we're not going to be able to do it. Also, our hand is the next biggest. So to be able to point or write or type, we have to have a great representation. Many of the kids that type and spell tell us that they don't feel their mouth. They don't feel their tongue. They don't feel their body. They don't know where their body is. They don't know where their hand is unless they're looking at it. And they can't move it. And that's why they can't speak. And that's why they can't write. And that's why they may not be able to point when they're asked to point. Or they may point to the wrong thing because they're not controlling it purposely. They don't feel their body. They can't move their body. That's why they don't speak. And that's the primary reason with nonverbal autism. And it's a right brain problem, and it's an interoception and proprioceptive problem. And it's not that they don't know the words. Because what we do know is that most of these kids know all the words. So all the words come from this back part here called Wernicke's area on the left. They know it. It's there. They may not be able to show it, but it's there. And it's there beyond their age. They know more than kids their age. But it's not because they have a problem with Broca's area on the left that they don't speak. That's not it. It's because of the right brain. And let me tell you the problem. Many people assume that that's the problem. And so they may try to stimulate that area of the brain. And that area of the brain is also near other areas of the brain that cause other issues. And when you stimulate the left brain, you make the imbalance worse, you make the speech worse, and you bring out other things like tics, stimming, and OCD. Because if we look at tics and stimming and OCD, tics come from that area 6 up there on the left. When it's overactive, it's normally inhibited and controlled by the right. OCD comes from 46 and 9 on the left and 11 and 12 on the left. Overactive, they're normally inhibited by the right. And so if you go by 45 and 44 is Brodmann area. That's Broca's area. That's the expressive language, which people think is deficient in autism. It's not. And what we see is that if you try to stimulate area, you're going to also, you may hit parts of 6 and you may hit parts of 46 and 9. And what we see is many of the stims and tics get worse. And so does the OCD behavior. And then also anger, which also is generated in that same area. And so that's why it's important to know this. If you want to be able to help a child to speak, you need to know what the reason is. In left brain deficits, the problem is in 44 and 45 and in Wernicke's area, and maybe in more of the motor areas of the brain. And then we want to stimulate that, and we may need to inhibit the right. But if you're talking about non-speaking autism, that's not the problem. It's the opposite. So this is why this matters, and matters why we do this. And, lastly, a lot of what we look at also is that many of these kids have other issues like food sensitivities or eczema early on, or they have dysregulation of the immune system, or they have digestive issues. And many people out there, well-meaning and very educated in the world of biomedicine, but not neurology, say, well, it all starts there. It starts in the gut. It starts with the body, and it starts with inflammation and food sensitivities. And then that works its way up to the brain, and that causes autism or ADHD or, any neurobehavioral. That's not how it works. Those things are important, but that's not the initiation. So we see that there's the sympathetic and parasympathetic nervous system. The sympathetic is the fight or flight. It's essentially there for when we're in danger. We know when we're in danger or scared, our heart rate speeds up and our pupils get larger and our hearing gets louder and our digestive stops. And then when we calm back down, the parasympathetic nervous system quiets us down. So it's called the rest and digest system, and it's more this social engagement, things like that. When we look at how this all works and develops, again, it starts in the brainstem. And the sympathetic nucleus is on fully when we're born. That's the way it's supposed to be. And that nucleus is there called the rostroventral lateral medullary nucleus. And that's fully on, and the sympathetic nervous system is fully engaged when a child is born. That's the way it should be. Their heart rate should be fast, and their digestion is shut down at that point. They really don't have digestive function because the nucleus that controls that, called the dorsal motor nucleus, is being inhibited by this. And so they don't really have a lot of gut function. And their their gut is open and leaky because that's how it starts out. Most people don't realize that. As the gut matures, it closes up and gets tight junctions and only lets small molecules. But it starts off open and leaky for a reason, because the baby isn't producing antibodies yet. The antibodies come primarily through their mother's breast milk, or that's what it's preparing to do. And these are large proteins that wouldn't get through a normal closed up, mature stomach lining. So the gut is open. That's the way it starts. And then what we also see is they're not producing acid and enzymes, which makes sense because those acid and enzymes would digest or kill those antibodies in the gut. We wouldn't want that. We also don't have a lot of blood flow or movement at that point. But as the brain stem matures, as the child goes through the milestones, as they start to move more and more, and as the reflexes are building up and then going away, what we see is the child starts to eat solid food maybe 6 or 7 months in, and they start to produce their own antibodies, and the gut is closing, and acid now starts being produced. Acid is produced to break up the solid food, and it also, what it does is it now creates the right environment for the good bacteria to thrive and grow and kill the bad bacteria. It also, the acid helps to kill anything that might come in on the food, like fungus or yeast or parasites or mold, that shouldn't be able to live or thrive in our body or in our gut if the acid and pH balance is proper. And then we get more blood flow to be able to now absorb vitamins and nutrients and minerals and amino acids that come from the food. And then we have movement of peristalsis so that we don't have constipation. What we know is happening, whether there's a left brain or right brain language delay, as long as these reflexes are there and those milestones haven't been fully met, then what we see is that this doesn't come on. So when we're starting to mature, and as the brain, as that medulla or the lower part of the brainstem matures, this nucleus, the NA nucleus ambiguus, comes online. It inhibits the sympathetic, the RVLM, and it activates the dorsal motor nucleus, and that's when the gut comes online. And that's when it closes up. That's when we get acid. That's when we get blood flow. That's when we get movement. And that's when the brainstem is fully mature. And then we go on to the next stage of development. And now we can provide this brain that's growing with the proper nutrients. But we know that that's not happening in brain developmental delay. We've proven that. How do we prove it? Well, we measure something called heart rate variability, which looks at the balance of parasympathetic and sympathetic. And we've shown that they're in a sympathetically dominant state. But we've also shown by getting rid of the reflexes and by doing hemispheric-based stimulation in the appropriate way, we can reverse that. We can speed up their brain waves, and we can get them to be able to move in a better way and be able to feel their body more and start to feel and connect, become more attached to other people, and in many cases, speak more. And ultimately, that's one of the things that we're looking to do. So we spent about an hour doing this. It's a lot of information in a short time. Again, this was just an overview. I'm going to go into more detail of this story and talk about how more specifically to change it. But if you really are interested in this, and if you have a child, first of all, without sounding, I don't want to egotistical, because I'm not driven. Anybody knows me, I'm not driven by ego. Right now, I don't think anybody else in the world knows this. I don't think anybody else in the world understands this fully. This has been my work that I've been doing for 25, 30 years, and it's only been really in the past 5 years that it's fully come together for me. And now we've developed a program that I think, and I know actually, is the most complex, sophisticated program using the best combination of tools. There's a lot of people out there on Instagram, and they're always showing, I'm using this new tool and this new tool and this new tool, and it's not about that. It's not about how many new tools you're using. I guarantee you we're using whatever is the most cutting edge that is really works and makes a difference, we're using it. But there's also a balance, because you have to use it in a reasonable amount of time. You also have to use it with enough repetition. And so we are able to pick through the most powerful tools and combine them together and it doesn't have to be many, and we want to do a lot of them. So it's not about, constantly bringing in new tools and doing all these different things. Also, diet and nutrition and immune modulation is hugely important, but it's not the root cause, and it's not going to ultimately get the bang that working on the brain and the gut at the same time, which understanding that the brain is taking the lead. So, it's about what's going to be impacted. And I work very hard with my staff, and our program really addresses this. And this is what we work with, and we get amazing results. And for me, giving the voice to a child that I know is a genius, and not take away the genius, but give them the voice to show the world that they are a genius. I don't think there's a greater purpose I could have, and I know my staff feels that way. And so, we consider it an honor to work with any children or any family or any patient that has any of these issues. So, if you want to reach out and learn more, you can go to my website, drrobertmelillo.com, and you can sign up for a virtual or a live consultation, or you can send an email to info@drrobertmelillo.com, and you can sign up at that point. If you are part of this live, I have incredible staff and associates, and they do a lot of the work here. I'm always around, but they really see a lot of and do a lot of the virtual consults. I'm involved in every live consultation pretty much if you come here and see me to some degree in the history and the exam. But if you want to do a virtual and you're part of this and you let us know that you were part of this, then we're going to do our best to schedule the virtual consult with me personally. And I hope I get a chance and an opportunity to meet you. I hope this resonated with you. This is pretty cool information, and it's very exciting, and I can't wait to share it with you in person or with your family or with your child. Again, we have many stories and many parents out there that can tell you that this is the way it works. I'm going to be probably putting out a story about one of the families that we work with for Autism Awareness Month. And what I want to bring in our message of our office for Autism Awareness Month is I want to raise awareness about how brilliant these kids are and how special they are and how we should not underestimate them. But they tell us the spelling when they tell us, please help me speak. Please help me to stop stimming. Please help me to, control my actions and my movements. And we can do that without losing their genius in measurable ways. So I hope we reach out. I hope you found this interesting and entertaining or educational. I appreciate your time. I never take it for granted. So thank you for all your support through the years. I hope I get to meet you in person. And we'll be putting this up, I think, in some way in my social media. I'm still old. I don't know all the terminology. But, it'll be available for people to watch. Okay? Thank you very much. Love you. Bye.